Okay, so here's just a quick introduction to the calculator video on how to graph some functions. So we'll try a few of these. Let's take a look at this first one. Y equals x squared plus 2x minus 1. So here's my calculator, my good old TI-83. And what I'll do is let's make sure you can see as much of it as possible. Let's get this up a little bit higher even, okay? There we go. So you can see the whole calculator. And we're going to put that function in. And it's up here. I guess I can put it over here so you can see it a little bit better. There we go. So we're going to put this in. And first of all, of course, we'll turn it on. Get this up here so you can see the whole thing. So it goes on down here. Oops, clear. Let's get back over here, clear this. Okay, so we turn it on, and you got to be careful that these little plots are off. These might foul you up if somebody was doing statistics with it. Make sure those plots are off. Now, we always want to make sure that we're in the right mode when we're graphing. Now, mostly in calculus, we're going to use radians. So you go to the mode, and you check all your modes over here. And the first one is radian or degree. If you're in degrees, if you're doing physics, all right, you're going to have degree. And that'll be highlighted. So that's, if you're doing physics on your calculator, that's what's going to happen. We don't use degrees, we use radians. So when you get over here, make sure your mode is in radians. Lots of times students get crazy answers and they wonder why, and they have their calculator mode in degrees. It should be in radians. So just move it over to radians and press enter, and we should be okay. And the setup should look pretty much like this. Okay. So hopefully that makes sense. And our function mode will be, well, our mode as far as the function will be function. This is the parametric mode, this is the polar mode, and this is sequential. That's why we have these numbers like, or these possibilities as x, t, theta, and n. All right. T is for parametric equations, theta is for polar equations, and n will come into play when we're doing sequences. All right, but we're just going to be doing functions in AB. So there you go. All right, so now let's kind of graph this. So we go to y, this y up here, and this is our graphing section, and we just put the value in. So we've got x squared, so we can put x. And then there's a little square down here, so I can hit that, and then I put the square on that, plus 2x minus 1. And there we go, and we're ready to graph. Okay? Now, we can graph this over here, and you can see this is a setup, and we have these different windows, and this is where we have windows where we can actually adjust this, and this is a zoom. These are set windows. So it looks like that was zoom 4. We've got zoom squares, zoom standard. This is 6, so try the standard and see what happens. What this does is this makes our increments here a little bit smaller. Now, if you look at the window, that actually tells you my x values are going from negative 10 to positive 10. It's flashing on that, but look at that. So my x values are going from negative 10 to positive 10. My scale is 1. That means each of those little notches is 1 unit. And I'm going from negative 10 to positive 10 on the y, the same scale. So if I go back and look at the graph, that negative 10 on the x minimum, negative 10 to positive 10, where that was the x minimum, and the scale being 1, that means that each of these little increments is 1. And then my y is going from negative 10 to positive 10, and each of these was 1. So that's how the window works. Sometimes you'll adjust that if you've got a function that the values are a little bit different. You may have to adjust the window. Okay, so that's all you have to do. Like I said, these standard windows, these zoom windows, zoom in if you want to get closer, zoom out. But zoom decimal 4 and 6 are pretty much the more standard ones. If you've got a trig, one like a sine or cosine, then you could use a zoom trig, and that's going to give you increments like values on their axis would be like pi or 2 pi, etc. Okay, let's go back and let's try another one. So we'll clear that. Now you can actually have 2 on here. You could put another one on here. So I'll show you this function. Let's say y equals x cubed plus 3x minus 1. So let's put this in the second box. Now, we can put x there. Now, instead of writing, there's a little caret sign you can write, but instead of writing a little caret sign, what you can do is you can go to math 3. See where it says, where's math over here? If you had math, and see how 3, this means this will put a cube root on there. So if you hit math 3, that makes that x cubed, so that's a little shortcut. Plus 3x minus 1. And then we can, now we can graph that. Now what this will do is this will graph both of these because they're both on. So if I want to turn one of them off, and I think I did this in some of the examples, or one of the homework problem sets. What I'll do is I'll turn that one off. So just press enter, and now you can see that the only one that's on is the second one. So this is going to graph the cubic. Okay? And I've turned off the first one. If I wanted to graph them both, I could put both on. Maybe we'll do that in just a second. So let's graph that. And there's your cubic. You can see that's standard cubic type equation. If I look at the end behavior, that's about the right end behavior. It's going to start low left and go upper right, so I think that's about what we got. Okay. Now if I want to go back and graph the other function also, I could turn that on. Now I got them both on. Now watch it graph both of them. Okay, there if you can check the intersection. So you can also do that. So that's pretty much all there is to it as far as graphing these. I think I graphed some rational functions in the homework, but you can take a look at that. So this kind of gives you an introduction. Okay, so I hope that helps. So this is your graphing mode. You put those in. You can go to math and use some different functions, so this will help you. And we'll do some more of these math functions. We've got fractions, we've got decimals, we've got, this is the third power, we've got cube roots, x roots, things like that. So there's a lot of handy things over here that can save you a little bit of time rather than writing caret. Now if you had x to the fourth, if you wanted to graph this one, what we can do is go back over here. Now let's clear that one, and go back up here. And now we don't have much choice here, so we can write x. And then if we want to get to the fourth power, we can use our little caret, power 4. Okay? Minus 2x plus 1. And that'll graph that fourth degree equation. Let's see what we got. So we got something like that. And that matches the end behavior, and we probably don't have it. We just have, it looks like, well, we'd have to zoom in. So let's go window, let's go zoom 4. So we can see a little bit better what's going on. See, it does go under. We couldn't see that, but you can't see that it goes under. Now, if you want to check values, you can always go to trace. And this will trace the values. And this will give you, for each x, this will give you the y. Okay? And if you want to find the value at a particular point, what you could do is you could go to second calculate, and right up here, number 1 will give you the value. So if you put number 1 in there, if you press enter for 1, it will say x equals. Now, if I want to find the value of the function at any particular x, I can do that. So let's say when x is 0, what's this equal to? In other words, what's the vertical position? And it looks like that would be the limit as x approaches 0, and it's y equals 1. And it looks like that is a limit. Looks like it's a continuous curve. So as x approaches 0 from the left, I'm approaching, my vertical position is approaching 1. And as x approaches 0 from the right, you can see my vertical position is approaching 1. Okay? So I hope that helps.